Start recording. All right, so I'm going to ask you the same question again. Do I have your permission to record you for the remainder of the term? You know, just in case I forget.
Yes.
Okay, very good. Awesome. So I am going to record, guys, every session we do on Zoom, all right? And then I just created the YouTube channel. It's called Professor Alcira. And that is where I am going to collect all the the Zoom videos into YouTube. So it's going to be a repository for all these videos, okay? It's called Professor Alcira, but I will be sending the links out to you guys on Blackboard, okay? So everything I do on here will be recorded. So once again, just to recap, for those of you just joining us, Gina, I see you there, okay? So if you're just coming in, remember, number one, you need to sign up for Mymathlab. Go into Blackboard and do that. The syllabus is also in Mymathlab. The link is in Blackboard. Just click on it and you can go into the syllabus. Now, we are going to be doing attendance as well. I'm sure you saw the attendance link in Blackboard. I'll be giving you a code to check yourself in very shortly. And then, guys, we are in the middle of discussing the syllabus. Now, on the syllabus, there's a total of 6 dates, okay, that I have published where we are going to be meeting face-to-face in S204, okay, on Thursday nights during our regularly scheduled time. Now, the room is an auditorium style, so they've already spaced out everything for us 6 feet apart. You are expected to wear your mask when we do come together in class. Our first face-to-face session is going to happen on September 10th, so make sure you wear a mask with you. Now, my intention is when I meet with you face-to-face, either I'm going to be teaching or I am going to be administering a test. So on the 10th, we are going to actually take our first test in class. It is going to be over chapter 5. And when I administer a test, guys, I like to teach first, review. I review over the test and then I administer the test. It is going to be 25 multiple choice questions on chapter 5. You will need a Scantron. You can pick up the Scantrons from the bookstore. All right. We'll talk about that a little bit more in a minute. But if the date is not on the syllabus, that means that we are on Zoom. And if you miss a Zoom session, you will get a link to the video where you can watch it. I'm actually going to be teaching you guys on this Zoom session. I don't believe in not teaching my students, okay? So guys, let's carry on with the syllabus. Besides the access code, the textbook, every once in a while I get students asking me, do I need the textbook? Do I need the textbook? Do I need the textbook? No, you don't need the textbook because there's an e-textbook with your Mymathlab access. So you really don't need the textbook. And I post all the example problems for you, all right? Now, for this class, we are taking 4 tests. I am going to be dropping the lowest one, and then there will be a comprehensive final exam put out by the department. The first test is definitely going to be in person on September 10th. It will be over chapter 5, 25 multiple choice questions. All right. Now, the second test is going to be over chapter 8. All right. And I think I have that slated for, let me see, I'm going to tell you when. Hold on a second. It's going to be on October 8th, and it's going to be online because chapter 8 is long. It's got a lot of formulas. It is going to be online on Zoom, okay? And that one, the majority of the questions will be free response, and you will have some multiple choice questions. I haven't decided how many multiple choice questions, how many free response questions. It just depends on you guys. As I move through the semester, then I'll decide. So for now, guys, I can definitely tell you the first chapter, chapter 5 in class. The second chapter, chapter 8 is going to be online. We're going to take the test. Now, the third test and the fourth test, I'm not sure about that yet, but I can tell you the fourth test is definitely in class because towards the end of the semester, We're going to be meeting regularly, 3 back-to-back Thursday until that final day of class. And of course, the final day of class, I will be administering the final exam, which consists of 30 multiple choice questions. By the way, the 4 tests will have 15 multiple choice questions. Okay. And then the 3rd test, depending on where we take it, if we take it online or if we take it on in person, that'll determine how many questions we have and what type of questions we'll get on there. All right, guys, listen, I know I'm saying a lot to you, so do me a favor. If you have a question, drop it in the chat for me so I can address your questions. I love questions. I need you guys to be clear about everything. So make sure you're dropping the questions in the chat box, all right? Now, emails. I answer emails Monday through Friday, regularly. Monday through Friday, I'm answering emails. However, my weekends are off limits. I love enjoying my weekends. I love traveling. I love enjoying life, guys. I love life. I live life. So therefore, my weekends, they are off limits. I don't answer emails on Saturday and Sundays, okay? Monday through Friday, I'm all yours, people, okay? So when you send me an email, make sure in the subject area you include MGF2107 so I know you're in my MGF2107 class, all right? Any questions, guys? Nothing? Oh, okay. Guys, I like questions. Ask me questions, okay? Either put in the chat box or go ahead and turn on your mic and ask me questions, any type of questions. Nothing? All right, so what I'm gonna do now is switch over. I'm gonna share my screen and show you guys the assignments. Where are my assignments here? Hold on a second. Let me find my list. Hold on a second, guys. I am going to go on Mymathlab and look at the assignments with you. By the way, we have a total of 20 assignments. There will be 11 homework and 9 quizzes. 11 homework, 9 quizzes. Hold on a second. Let me double check on this.
I had a question. My last I had 2 math classes before and they all did it differently. The first one, each assignment was its own grade, but the second class, they were all warped into one big grade. How is it for your class?
Okay, all the assignments will be worth 20% of your grade for the class. 10% will go towards your quizzes, 10% towards the homework section. And then the test will be worth 80%. And pretty much we take 4 tests, drop the lowest, and then a final exam. So what it equates to is 20% per test. Okay. Does that answer your question?
Yes, thank you.
Oh, no problem, anytime. All right, I'm still looking for my assignments, guys. I'm not seeing them to share with you. Shazam. Where is that screen? Okay, I'm not seeing it, but let's see if I could share this one with you. All right, everybody, hold on. Technology, it works when it wants to. Okay, this is not what I wanted to share. Okay, so since I cannot, guys, pull up my part here on Mymathlab, why don't you do this for me? Why don't you go ahead and pull up another screen with Mymathlab? If you go under assignments, you will see where I have posted all the assignments for the class. If you wish to, you can always work ahead. You do not have to keep pace with me. You can work ahead if you want to. And of course, there are due dates associated with each set of assignment. And as I mentioned before, guys, what I want to do is focus on the first 2 chapters, chapter 5 and chapter 8 for now, to see how we progress through the semester. So I want to focus on chapter 5 and chapter 8 first. So the chapter 5 assignments will be due on September 10th. And then the chapter 8 assignments will be due on October 8th. Now remember, I am very flexible, guys, very flexible. So this means that if I feel I haven't really gone over the material for you to understand it, for you to do well on your test, and I need to postpone the assignments, I will always do that for you. If I postpone the assignments, I'm definitely going to postpone the tests. Definitely. All right, I'm going to try and share the screen with you one more time. Hopefully it works this time around. Okay, it's coming. My internet is really slow. By the way, guys, are you seeing a number on the screen right now? It says take attendance. Yes, no?
I see the quickly, but
Okay.
what's your code for it?
It's right there on the screen. It's 4991. I'll type it in the chat box for you. That's not really what I wanted to share with you, but this is what popped up. So for now, just go ahead and write that number down. I'm going to drop it in the chat for you. Let me go ahead and drop it in the chat. This is how we're going to do our attendance. So 4991. You have to make sure you do it by 8:30, guys, is the attendance code. All right, so that's in the chat box. I'm going to try and get that Mymathlab working on here somehow or another. I don't know why it's not working.
What's the course ID for the, I tried the name that was on the syllabus, but it's not registering for some reason.
You don't need a course ID. Did you go through Blackboard?
Yes, I'm on a Pearson to register for a class.
Okay, and you on Blackboard? You have to go through Blackboard.
Oh, through Blackboard?
Mm-hmm. Oh my goodness, it's still not sharing, guys. I don't know why it's not sharing. Okay, I'm gonna try this one more way and see. Let me get rid of the quickly attendance. Okay, make sure you guys do your attendance, please. And then let's try it one more time. Hold on, I'm still trying to get in here. Oh my, I got the wrong thing again, guys. It's just not sharing for me right now. Okay, since it's not cooperating, people, I guess I will try this later on. The attendance code, guys, is 4991. I've also included it on the chat box. Now, if you scroll towards the bottom of the screen, you will see where it says chat. Click on that, all right? And I am going to be starting with the teaching session. Now, at the bottom of the screen, you will see what says reactions. I like to get my students to participate. So the reactions only, it only has a thumbs up and an applause, guys. I thought I had more emoticons than that. Wow. Okay, I need to update the Zoom. All right, guys. So listen, since I cannot get Mymathlab on here, what I want to do is start teaching, and then I'll come back to it in a little bit. And if you think of any questions while I'm going through the lesson, please go ahead and drop your question in the chat box. I'll be more than happy to answer it. Now, guys, during the test, you are allowed to have a calculator. So get yourself a good calculator. It doesn't have to be a graphing calculator. Basic scientific calculator will work just fine. I think I have a little one over here. I have this one right here that I'm consistently using unless I'm in a college algebra class. So I use this one all the time right here. This is perfectly fine for a class like this. If you want to get one of the larger graphing calculators, that's fine as well. And yes, I am going to be doing demos on the graphing calculators from time to time on here. All right, so do you guys have any questions to me? If you don't have any questions, you know, I am going to start teaching. So ask me questions, guys. I love questions. Nothing?
I do.
Okay, go ahead.
I'm sorry. This is my first ever like online anything.
Ah,
So I don't know. I don't know what you're talking like with finding attendance, how to do that, or I don't know what I'm looking at or what I'm looking for.
okay, Savannah, you're going to go into Blackboard.
Okay.
All right, on Blackboard, you will look at the left side of the screen and it says attendance. You want to
Okay.
select that. And it's
Okay.
going to ask you for a code. And the code
Okay.
is 4991. That's how you check yourself in.
Okay. Thank you.
No problem. I love questions, so keep asking your questions, guys. Anybody else? No, that's it? Wow, guys, I'm surprised. Okay, so let me go ahead and put in this password here because I'm trying to get over to my iPad so I can start the teaching. What I do is I teach off my iPad and project it to you guys. And so all the notes will be a part of the recording. Now, as we do this, guys, remember, I like questions. Drop your questions in the chat box, and then I will answer them for you as I notice the questions, okay? And if for some reason I am writing and you cannot see my writing, please let me know so I can go and adjust the screen and do what I need to do to make sure you guys are seeing everything. All right, let me see here. Okay, let me share. Okay, hold up a minute. I gotta fix something right here. Okay. All right, guys, you should be seeing a white screen now. All right, perfect. Okay, everyone. So I am going to start with chapter 5, lesson 5.1. And remind me later on to go and attempt the Mymathlab assignments one more time. So lesson 5.1, guys, is where we're starting. I am going to give some notes. Now, remember, all of this is being recorded. So if you cannot keep up, that's okay, because you can always go back over the video. And once I upload the video, I will send you a link through Blackboard. So you can just click on the link, it'll take you directly into the video. All right, so I'm starting off with number theory, guys. Lesson 5.1, and we're looking at prime and composite numbers. All right, so here we're looking at the definition of a prime number first. A prime number is a number with only two factors, one and itself. So a prime number is a number that has only two factors, one and itself. So the smallest prime number we look at is 2. There are only two numbers that can go into 2 evenly. That would be 1 and the number 2 itself. Another prime number is 3. There's only two numbers that can go into 3, 1 and 3. So guys, the smallest prime number is 3. And so when we talk about these numbers right here, and we're looking at the prime numbers, we start off with 2, followed by 3. The next one is 5. Then we got 7. Remember, these are all prime numbers, numbers that has only two factors, 1 and itself. Now, the next one we look at, 9. Is 9 a prime number, guys? Give me an answer in the chat box. Yes or no? Is 9 a prime number? All right. Okay, I see you guys. No, no, no. I have a couple of yeses. Remember the definition of a prime number. It has to have 2 factors, 1 and itself. So 9, what numbers go into 9 evenly? Well, 1 goes into 9. What else? Well, we also have 3 and we have 9. So this one has actually 3 factors, not 2 factors. So guys, this is not a prime number. So I'm going to go ahead and get rid of that one. That's not a prime number. So after 7 comes the number 11, followed by 13, 17, and so forth and so on. These numbers go on and on to infinity. Okay, prime numbers go on and on to infinity. So guys, any questions about the prime numbers? No? All right, so let's carry on then. Now, the next one, if a number is not prime, we call it composite. So the composite numbers, unlike the prime numbers, are numbers with 3 or more factors, or more than 2 factors. So any number that has more than 2 factors, we call it a composite number. So what numbers are we talking about? Numbers like 24. Actually, you know what? Let's go back to 9. We just saw 9. We just talked about 9. So let's talk about 9 again. We got 3 numbers that can go into 9. 1, 3, and 9. So this one has more than 2 factors, so it's considered composite. Here's another one, 24. What numbers go into 24? 1 goes into 24, 24 times. 2 goes into 24, 12 times. 3 goes into 24, 8 times. 4 goes into 24, 6 times. And of course, we got 6 that goes into 24, 8 goes into 24, 12 goes into 24, and then of course, the last one has to be the number itself. So guys, 24 is definitely not a prime number. Now, the next part of this is to prime factor. We're gonna prime factor. Now, what does it mean to prime factor a number? Another way we look at prime factors is the factor tree, guys. Remember the factor tree from grade school? This is the same thing. When they ask you to prime factor a number, we're looking for basically a factor tree of the number. So basically, when you're doing prime factoring, you're finding all prime factors, all the prime factors, guys, all right, whose product, by the way, means multiplication, is the number. So when you're prime factoring, product means multiplication. When you're prime factoring a number, you're looking for all the prime factors that will multiply to give you that number. So let's prime factor 24. We're going to prime factor 24. Prime factor 24. So we take the 24. I'm actually going to use the factor tree. We ask the question, what 2 numbers multiply to produce 24? What are 2 factors of 24? It doesn't matter what they are, guys. For example, I could use 4 and 6. Somebody else could use 2 and 12. Someone else could use 3 and 8. It doesn't matter. We're just going to prime factor that 24. We're going to break down 24 until we find all its prime factors. Yes, Tennille, I see that, 12 times 2. So guys, next question, is 4 a prime number? No. So then we're going to find 2 factors of 4, 2 numbers that multiply to give us 4. Is 6 a prime number? No. So we're going to find 2 factors of 6. So 2 times 3 will give us 6. Now look at those numbers at the bottom. The 2s, the 3, are those prime numbers? Absolutely, they are prime numbers. So guys, since they are prime numbers, all of them are prime numbers, we have our prime factors. So the prime factor for 24 will consist of 2 times 2 times 2 times 3. Now, if you were to multiply all 4 of these numbers, that should produce 24. Now, you notice the 2 is repeating 3 times. So rather than writing it as 2 multiplying by itself 3 times, we're going to use exponents to show this, that the 2 is multiplying itself 3 times. So we write the 2 that is multiplying itself 3 times. And so we're going to raise it to the 3rd power to show that multiplication by itself 3 times. And then we're going to multiply it by the extra 3 here. So guys, when they ask you for the factored form, this is what the factored form is going to look like. 2 to the 3rd times 3. Now, okay, you guys need to find the emojis. Remember, I want you guys to participate. Give me a thumbs up if you feel comfortable with the factor tree. Awesome, I'm seeing a lot of you guys, okay? Ask me questions if you don't get it. Okay, excellent, I love it. Okay guys, so here comes the next part. And the next part has to do with finding the GCD. You guys take a guess at what the GCD represent. Take a guess at that. What does GCD mean? What does the acronym GCD stand for? All right, I'm seeing greatest common denominator. I love asking this one, guys. In this instance, since we're not talking about fractions, it's actually the greatest common divisor. Divisor. Yeah. And when we talk about the greatest common denominator, we're looking at an LCD, you see? Aha. Okay. So in this case, guys, we're looking for a divisor. All right. So to find the greatest common divisor, number 1, we want to list the prime factors. Oh, I forgot to put list. List the prime factors. Oops. List the prime factors of each number. Of each number. By the way, I love abbreviating too. Okay. Number 2, circle the like factors. Circle the like factors, guys. If you cannot read something, let me know, everybody. And then number 3, find the product, and remember product means multiplication, of the like factors. So in other words, you're going to multiply all of them together. All right. Now, I am going to go ahead and look at an example with you guys. So once again, you want to take each number, factor them into their prime factors, and then circle the like factors and multiply all the like factors together. So I'm going to delete this. All right, guys, so here's the first example. I've got 60 and 108. So we're going to practice prime factoring. Now, when I do my prime factoring, okay, especially on here, since I'm limited with space, I like to do it horizontally, but I'm going to do the factor tree with you guys once again, just so you can be comfortable with it. I'm going to prime factor 60. 60 is 10 times 6. 10 is 2 times 5. 6 is 2 times 3. All right, so I've got all the prime factors of 60. So for 60, I've got 2 times 2 times 3 times 5. These are the prime factors for 60. Then I'm going to do it for 108. Now, for 108, guys, because it's even, I'm just going to do 2 times 54. 54 is even. I'm going to do 2 times 27. Now, 27 is an odd number, so I'm going to break it up into 3 times 9. And 9 is not a prime number, so I'm going to break it up into 3 times 3. So the prime factors for 108 will therefore be 2 times 2 times 3 times 3 times 3. So I've got all my prime factors. Any questions? All right, guys. So the next step, we're going to circle the like factors. We got a pair of 2s, another pair of 2s, a pair of 3s, and that's it. Those are the like factors. Remember, the GCD is a product of the like factors. So the like factors are 2, 2, and 3. We multiply them together, and we end up with 12. There's your GCD. All right. Now, unfortunately, I didn't download my graphing calculator yet, but there is a way to do this on the graphing calculator to get the GCD and the LCM. Next time, I will show it to you guys. All right, everyone, how are we feeling about this? Okay, let me see.
Can you do just one more example?
Yes, absolutely. I love questions like that. Remember, I love questions, guys. Okay. I'm concerned when I have a class that doesn't ask too many questions. So here's another pair, 120 and 72. So we're going to list the prime factors. Now this time, just to expedite the process, I'm going to go horizontally. You know what? Let me just keep doing that factor tree. Let's keep doing that factor tree. Okay, guys. So 120, pick any 2 numbers that multiply to give you 120. I'm going to pick 10 and 12. Any 2 numbers, it really doesn't matter. 10, now once you select your 2 numbers, you have to ask yourself, is this number prime? Is this number prime? Is 10 prime? Is 12 prime? No, they're not prime, so that means that you have to break them down some more. So 10, remember, is 2 times 5. And I'm going to do the same thing with the 12. Is 12 a prime number? No. So I'm going to break it up into 2 times 6. And then I'm going to ask the question, is 6 a prime number? No. So I'm going to break it up into 2 times 3. All right, so now I'm going to go to the side and list the prime numbers for 120. So 120 has the following prime numbers, 2, 2, 2, 3, and 5. So those are the prime numbers for 120. Then I'm going to do the 72. Now 72, 2 numbers that multiply to give you 72. It doesn't matter what they are. I'm going to do 9 times 8. Is 9 a prime number? No. So I'm going to break it up into 3 times 3 because 3 times 3 gives me 9. Then 8. Is 8 a prime number? No. So I'm going to break it up into 2 times 4. And then the 4, I will break it up into 2 times 2. So now I'm going to go to the side and write all the prime numbers for 72. So 72 is 2 times 2 times 2 times 3 times 3. There's a 3 at the end there, guys. Okay? All right, everyone. So now I'm going to circle the like factors. I got 1 pair of 2s, and another pair of 2s, and another pair of 2s, and 1 pair of 3s. So my GCD will consist of the product of 2 times 2 times 2 times 3, which gives me, hold on a second, 24, guys. I was about to put 18. Shame on me. All righty, guys. That was the second example. Give me a thumbs up if you're getting the GCD. Awesome, 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 awesome. All right. So now I am going to move on to the LCM. All right. Now for the LCM, it's very similar to the GCD. So you guys take a guess. What do you think LCM means this time? Shazam. What's LCM? Oh, somebody got it the first time. Gina got it. Taneo got it. Awesome. Awesome. Least common multiple. As in a multiplier. As in multiplication. What does multiplication do to numbers? It makes things larger, guys. Okay, so when you multiply, you're multiplying so you can make things larger. So we're looking for the least common multiple, meaning we're looking for a large number, not a small number. Divisor is a small number. Multiple is a larger number. All right, Kiara, I see you, Kiara. All right, guys. So for the least common multiple, like I said, it's very similar to finding the LCD. The first step is to go ahead and list all the prime factors of each number. Okay, number two, you want to circle the like factors. I'm telling you guys, it's very similar to the other one. All right, now here's the catch. Number three, the LCM is a product. Find the LCM by multiplying all like factors and remaining factors. Ooh, what does that mean, remaining factors? All those factors I didn't circle, guys, they become part of it too. When we're doing the LCM, we're multiplying not just the like factors, but all the remaining factors which we did not circle. All right, so I am going to go ahead and do some examples. Remember, guys, if you're missing anything from the notes, you can always go back over the video and look at the notes again. All right, so I'm going to erase this. You guys are good? All right, so here we go. I'm going to go back to the 60 and 108 again. Now, for the 60 and 108, we already have the prime factors for 60. It is 2 times 2 times 3 times 5. And then we had the prime factors for 108 as well because I used them earlier with the GCD example. It was 2 times 2 times 3 times 3 times 3. Now, step 2, we're going to circle the like factors. Step 3, we're going to find the LCM. The LCM is a product of all the like factors, 2 times 2 times 3. And then you want to include all the remaining factors. These are the remaining factors, guys. So they get included as part of the LCM. So now you got to sit here and multiply all of this together to get the final answer. That's what I'm talking about, guys. Okay? So somebody multiply all of this for me, please. Give me the number. So we're multiplying all of these numbers together, and that will give us our LCM. All right. Thank you, Taneo. Thank you, Jules. Awesome. 540, guys, is your LCM. All right. One of my bad habits is telling people what's going to be on the test. So I can tell you right now, there will be a GCD as well as an LCM question on the test, guys. One LCM, one GCD question on the test. So I'm going to do a second example with the LCM. And if you guys remind me, the next time I see you, I am going to show you how to do it on the graphing calculator as well. Remember, you do not need a graphing calculator for this class. Okay, we're going to find the LCM between 120 and 72 this time. So here we go, guys. We're going to list the prime factors of 120. We've already worked with the 120. The prime factors of 120 are 2 times 2 times 2 times 2 times, oh, I lost my train of thought, guys, times 3 times 5. You guys check me on that. Make sure I'm right, okay? 72. We're going to list the prime factors of 72. For 72, it's 2 times 2 times 2, okay? And then times 2 times 3 times 3. Did I put too many 2's in there? I think I put too many 2's in there. Okay, let me see here. Oh, I certainly did, because this is going to be 16 times 9. That's definitely not 72. So let me erase some of these 2's here. Okay, that's better. All right, everybody. So now let's circle the like factors. Bam, 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 and bam. There's the like factors. Now we're going to find out LCM. The LCM consists of a product of all the like factors and any remaining factors. That's a remaining factor. That's a remaining factor. So that becomes part of the LCM as well. So we're going to multiply all of this together, guys. 2 times 2 times 2 times 3 times 3 times 5. And that'll give us a whopping 360. And there we go. So guys, that was the second example with LCM. All right, give me a thumbs up if you want another one. Okay, Christian gave me a thumbs up. I'm guessing you got it, Christian. Okay. Do you want another one, Gina? You guys were supposed to give me a thumbs up if you want another one. Okay, Erica's giving me a thumbs up. Okay, awesome. Okay, now guys, just a reminder, if you did not do the attendance, make sure you do the attendance. Okay. All right, so I'm going to do another example with the LCM. Actually, you know what? Let's do both LCM and GCD, because on the test, you will get both. All right, so we're going to do the LCM and GCD between 300 and 144. Okay, I want you guys to give it a try. Let's see if you guys come up with all the prime factors for 300, all the prime factors for 144. You guys go ahead and give it a try. Awesome. Ask me questions if you guys don't get it. Drop your questions in the chat box. And then after this one, I'm going to try again, guys, to go on Mymathlab. Remember, I'm supposed to be teaching for the first hour, and then after the first hour, I will stop and do some questions. I probably have one more problem to go with you, and that will be a word problem. And I'm going to try on Mymathlab so I can get that word problem. Hopefully it will work for me this time. And then after I'm done with that, I will go ahead and either let you guys ask me some additional questions, or you are welcome to say good night, people, to call it a night, okay? So let's see here. 300, what'd you guys get for the prime factors of 300?
5 more minutes?
Huh?
5 more minutes?
No, I mean, listen, I'm gonna take I have you guys until 8:20, by the way. But because I'm not really required to teach, so I don't want to keep you guys sitting here in front of a computer screen for 2 hours. So I'd rather do 1 hour of teaching and then dedicate the additional hour maybe to some questions, okay? So yeah, kind of like 5 more minutes. We'll play it like that. All right, guys. So for the 300, you should have gotten 2 times 2 times 3 times 5 times 5. Is that what you guys got? Okay, 144. 2 times 2. Okay, let me see. 72, 36, 18, and then times 3 times 3. These are the prime factors, guys. All right, I love it, Brianna, I love it. Okay, so we're gonna go ahead and circle the like factors, bam. And then we have one more pair right here. I'm trying to get to them, bam. Those are the like factors, guys, that's it. So now the LCM will consist of a product of the like factors, 2 times 2 times 3, and then all the remaining factors. What are the remaining factors? We got 5, 5. We got 2, 2, and 3. And then you multiply all of it together, and that will give you your LCM. Okay, guys, what we get for the LCM? Ooh, this is a huge number. Okay, 3,600, that is large. Awesome. Now, big question for you guys. I didn't do the GCD. Somebody tell me what the GCD for this one is. What's the GCD for this one? Awesome, awesome. Tanio, 12. It's a product of the like factors. So 2 times 2 times 3 gives you the GCD. All right, everybody. So if you see those questions on the test, are you going to be okay with those? Awesome. All right, so I am going to take this off the shared screen. I'm going to stop sharing this one. And then I am going to go ahead and see if I can share my MyMathLab with you guys. Guys, it's still not working. I don't know what's going on with this thing here. Why is that not cooperating with me? Let me see. I'm going to try one more time. That's not the screen I want to share. Okay, one more time. Come on, work. Nope. All right, I am not quite sure what's going on. Let me see. Would somebody else like to, anybody on MyMathLab right now?
I am.
Okay, if you are, can you go to that first homework assignment for me so we can grab a word problem from there?
Yes.
Okay. And you can share your screen with us too.
Oh gosh.
No, it's at the bottom. It's at the bottom.
Okay.
It's fine.
Share screen.
You see what says show screen?
Okay, it's telling me my entire screen, application window, or Microsoft Edge tab. So should I do the entire screen?
Yeah.
Okay. I got you.
Can you see it?
I can see me. There you go. Okay.
Okay.
So, okay. Go into the questions. I'm not sure which one is the word problem, but there's a word problem in there somewhere.
1, 2, 3.
Okay, just go into any one of those questions.
Any of them?
Yeah. And we'll look for a word problem.
Please. Please. Please.
Okay. Go back a little bit. Go to the previous question.
More?
That's a good one. You know what? Let me see. Those are big. Okay, go back to number 5. Number 5 is nice, and we'll do that one. Okay, perfect. Now, do me a favor. Can you try and zoom in on your screen? I think it's the Control++. Just hold on to Control and plus. And now I think zoom your screen. There you go. Awesome. See, now we're learning. All right, Savannah, thank you. So guys, here we are, a word problem pertaining to what we're discussing. So you and your brother both worked the 4 p.m. 2 midnight shifts. You have every 6th night off. And your brother has every, oops. Okay.
Oops, I'm sorry.
That's okay. That's okay. Okay. There you go. Okay. Your brother has every 4th night off. Both of you were off on August 1st. Your brother would like to see a movie with you. When will the 2 of you have the same night off again? So guys, for a question like this is an application of either GCD or LCM. So the big question is, how do you know if you want LCM or if you want GCD? Do you want the divisor, which is a smaller number, or do you want an LCM, which is a larger number? Now remember, one of you gets the 6th night off, the other one gets the 4th night off. You guys want to see a movie together when both of you are off at the same time. So do you want to go to more days? Is it going to take more days for you guys to have the same night off? Or is it going to take less days for you to have the same night off? So if it's going to take less days for you to have the same night off, then it's going to be GCD. If it's going to take more days, then it's going to be the LCM before you can get the same night off again. What do you guys think? GCD or LCM? Type it in the chat box for me, guys. GCD or LCM? Should we find the GCD or should we find the LCM? Okay. How many times do we have to keep getting the 6th night off, the 4th night off until we have the same night off? Is that an LCD or is that a GCD? LCM or GCD? All right, guys. So let me go ahead and go back to this. Oh, Shazam, I turned off my Zoom meeting already. Guys, this one's going to be an LCM. LCM. How do we know it's an LCM? Because you're going to have to count the number of days before you can get the same night off. So if you're, you know what, listen, I'm going to go back on my little board here and we are going to go over this. Savannah, do me a favor, you can get up the screen.
I'm sorry, it got really loud. I couldn't hear you.
Okay, I think somebody's mic is on. So I don't know whose mic is on. Can we turn off the mic? Savannah, go ahead and you can remove the sharing. You can stop sharing. Okay. Thank you so much. Okay.
No problem.
All right, guys. So I'm going to type this one just to expedite the process because I want to go ahead and honor your time. We are going to do an LCM. Tanio said LCM. Jules said LCM. Awesome, ladies. Okay, so we're going to find the LCM between 6 and 4. So we count by 6. 6. Here, let me type it in the chat box so I don't have to go on Zoom again. 6, 12. Okay, then we're going to go ahead and do 18. Then we're going to do 24. We're looking for the number they have in common, ladies. The number they have in common, ladies and gentlemen. I just said ladies. I don't think I just have ladies. Now let's count by 4, guys. 4, 8, 12. And then you've got 16. Then you've got 20. Then you've got 24. Then you've got 28. Now, guys, look at the chat box. What number do they have in common? Can I show my whiteboard? I hear you. I got off the Zoom meeting already, so I'm going to have to go back on my whiteboard to the Zoom meeting, okay? Hold on a second, guys. Let me go ahead and go back in, okay? So, guys, what number do they have in common? 24. So that means in order for them to have the same night off again, it would have to take 24 days for the 2 of them to have the same night off again. Now, when you do this question on Mymathlab, you will get a drop-down menu. And that drop-down menu will give you 4 options to select from for the correct answer, guys. Samantha, can you tell us what the options are, please?
Yes, 1 second.
All right.
It's
that's
August. It's August 11th, 13th, 12th, and 10th.
Okay. August 11th, 12th, and what's the other one?
13th and the 10th.
Okay. All right. So guys, hold on a second. Let me finish typing this on. Just give me a moment. I'm almost there. And then I will definitely be able to show this to you so you could see it. Because I know sometimes you just got to see it to believe it. So, all right. Hold on a second. I'm almost there. And let me go ahead and share my whiteboard with you. All right. So guys, here it is. Here it is. So we're finding the LCM between 6 and 4. Now, let's use that method we just talked about. The prime factors of 6 are 2 and 3. What are the prime factors of 4? 2 times 2. We circle what they have in common. They have a 2 in common. That's it. So the LCM between 4 and 6 would be 2, what they have in common, times this 2 and times this 3 right here. So when we multiply all of it together, we get 12. So guys, this means it's going to take 12 days for these two individuals to have the same night off again. Okay, Jules said 12, Taneo said 12, awesome. Okay. Oh, was that for a previous problem? I think that was for a previous problem. Okay. So guys, if both individuals were off on August 1st, when is the next day they're both going to be off? If they're going to be off 12 days from August 1st, what do you guys think? Is it the 13th, the 12th, or the 11th? The 13th. 12 days from August 1st is going to be the 13th. Now, if that's a bit confusing, guys, remember, you don't count August 1st now. If that's a little bit confusing, count it out. No, 24 doesn't work. 24 is not the smallest number. Let me go ahead and show you this as well, because I know the 24 did pop up in the chat, but let me show you this as well. If you count by 6, 12, 18, 24, and so forth and so on. If you count by 4, 4, 8, 12, 16, 20, and so forth and so on. What's the smallest number they have in common? They have the 12 in common. By the way, this is how we used to find the LCM in grade school, but it was a very long process. So rather than doing it that way, we use prime factors instead. It is bigger. Okay, good point. I like that you asked that question, Taneo. Okay, so I'm glad you brought that up. Remember earlier I said LCM, M meaning multiple, represents a multiplier, so it's a large number. When we say a large number, we're meaning it's going to be either equal to this number or greater than this number. It's going to be larger than or equal to the 6, which was the largest number we had working with. Okay, it has to be larger than the numbers we're working with. We're working with 6, we're working with 4, so they have to be larger. And plus, 12 is a multiplier of 6. It's a multiple of 6. And 12 is also a multiple of 4. Another way you could approach this is to ask the question, what is the smallest number that both 6 and 12 can go into evenly? The smallest number that 6 and 4 can go into evenly is 12. Yes, 24 works, but that is not the least common multiple. Notice I'm saying the least, the smallest multiple. So the smallest multiple in this case would be 12, not the 24. Okay, guys, ask me a question. I can see some of these looks are looking a little bit baffled. So guys, talk to me, turn on your mics and talk to me. Let me stop sharing the screen so I can see everybody talking to me. And let me know what's going on, guys. What are you thinking about? Okay, are you confused about something? Do you need me to go over something else with you and clarify it? Remember, I love questions. Don't leave here without your questions. Okay. All right, guys. Let's see. Erica, how you doing? You all right? Is it too much for you? Are you overwhelmed?
No, I'm good. I'm
Okay.
good. I guess I was kind of confused because you had left off a 2. So I thought it would be 24 as well. Because when you circle the 2 and the 2 for the like, and then the 3. So I was confused, but I forgot. Never mind. I got it.
You sure?
I'm positive.
I like questions.
Nope, I got it.
Now, guys, if we were to use a 24, would we find the correct answer?
No, I got it now.
No, we would not. And remember, it's a drop-down menu. They give you the correct answer in the list. The 24 wouldn't work in this instance. Now, if you were doing fractions, you were adding, subtracting fractions with different denominators, it would work. But in this instance, no. That would be a long time for the two of them to wait to go to the movies. Okay.
But when I'm actually on Mymathlab for question number 5 that we were doing, April 13th is not one of the days. It came out to be the 22nd, 25th, 23rd, or 24th.
Okay, now
question number 5.
Okay, what are your numbers?
It says 22nd, 25th, and so maybe that wasn't question number 5 we were looking at.
Okay.
Oh, I get it. So she has something different from what my screen say. Never mind. I see it now.
Okay, so maybe your questions are not in the same sequence. I'm gonna have to go check that.
Correct. That's what it is.
Okay. I will definitely fix that for you. So next time they could be in the same sequence. Okay. Now, guys, okay. I'm glad Erica said that. Remember, when you go on here to do your problem, every time you go on, you'll get a different set of questions. So don't think just because Savannah got that question. I think it was Savannah. Was it Savannah? Oh, yes. Okay. Just because Savannah got that question doesn't mean that Erica's going to get the same question. Everybody gets a different question, guys. So be careful with that, please.
They are all unlimited tries, right?
Yes, absolutely. Okay. In some instances, I've seen professors put a time limit on the quizzes. I don't like restricting time when it comes to quizzes, guys, because I know everybody works at their own pace, especially when you're at home. I just can't do that to you guys. So I took off the time restrictions. Yeah. All right. So this is where we are, guys. I'm ready to let you go, but you're welcome to remain after. I'll be here until about 8:20 so I can answer your questions. Thank you, Tennille. It's been a pleasure seeing your beautiful face. Oh, Shazam, I know I'm trying to say something. It's been a pleasure seeing these beautiful faces. Guys, listen, we're going to get through this. I know it's a difficult time for you, but we'll get through it. I'm just going to go ahead and stop this recording here. Once we're done,